While on the sieving page, we're now going to discuss how to create a recipe. So, what is a recipe? A recipe is a listing, a pre-established listing of sieve screens, vacuum pressure, sieving time, boost time, as well as pass or reuse. So let's go here. We're going to add a recipe. We're going to create one. Now, one thing I do want to bring to your attention is that if you have a keyboard established, please bear in mind the keyboard becomes your primary. So if you're on numlock, if you're on cap lock, the characters displayed will be that of whatever you're on. So don't be surprised if you're getting incorrect values when you're typing. Always refer back to your keyboard and confirm what's supposed to be there and what's not. Okay, so now we're going to create this video. Now, notice the green because we're in the create mode. So, and these cells have been grayed out. So you can see the user is still admin because that's what we signed on as. Now what you can do is you can change your pass or retain or reuse and new. I tend to like reuse simply because once you have a sample, the morphology or particle size distribution is the same. If you go with new, every scoop of sample could be slightly different. So we were going to press the next. Primarily micron is the selection criteria. Mesh is typically an American or ASTM nomenclature. However, if you're concerned about ISO screens, you scroll all the way down, you'll see that the micron sizes are also listed here. To expedite the selection of the screen, what you might want to do is put 10. Alright, so we're going to go next. Now, anything or any screen that has a 10 in it will be shown in the selection chart. So we can now select, let's say 106, and then we'll select 2000, but we'll also select 150 micron. Now we go next, just to proceed if those are acceptable, proceed. And as I mentioned in an earlier segment, that we need to introduce the vacuum pressure. Vacuum pressure can range anywhere between 8 to 16 inches. We tend to recommend 12 inches here because it's the mid-range, gives you some flexibility. Sieving time. The sieving time is the total length of time that you want the air to flow or the vacuum to fluidize the material between the sieve cover and the sieve screen. We tend to recommend here at Hosokawa Micron Powder Systems 120 seconds. Now, the boost time for screen number 1. The boost time is the time that you want the wand to rotate 20% higher than the normal speed. Now, in this case here, if you don't want it to rotate any greater than the normal speed, you must enter a numeric value. So we'd enter 0. And it goes through and follows along with each of them. So if you look at it now, you have 12 inches of water, 120 seconds time, and then you have 0 boost. Now we could go through and we can continue selecting the various pressure and times for each of the screens. However, for this particular demonstration, I just wanted you to be aware of the fact that notice I selected 3 screens in random order. However, the software populates the screens in the finest order first. So the smallest micron opening first, followed by the next course and the next course. So let's go back and let's get rid of this one and this one, and then we'll go to next, and now you must re-enter that again. So 12-inch, and then we're going to run at, because of the demonstration, we'll run at say 15 seconds, and we'll run at 0. But now we're going to add the recipe. To run this particular recipe, we now must select it. Notice, there it is. If you wanted to edit it, you press the pencil button. If you wanted to delete it, you press the trash button. Notice the 4 buttons above are grayed out. That's because you cannot edit those, nor can you delete them. Now let's run a temporary recipe. Temporary recipe is just that. It can be run by the admin, the power user, and the test user. So now what we're going to do is we're going to put in a company name. Many people say, why do you put in a company name? I know my company. Well, because you may be performing this analysis for R&D. You may be performing the analysis for production. You may be performing this for quality. And basically that's how I would suggest you put in, let's say R&D, and then we progress. Now, this you do not modify because this is the user that you've signed in with. So we're signed in as an admin. That's how we're working it. Sample. We're just going to call it test. Let's call it test 1. And then lot number. We'll call it today's date. I do my dates a little bit differently than most, so we'll do 19/08/06. Okay. And as you can see, we can select the pass, retained, reuse, or new. Considering we're probably going to select one screen here, it really is irrelevant. Next. So let's go back and get rid of this. Clear. And we'll exit. And as you can see now, you have the complete listing again. And it will just arbitrarily pick a 45 micron screen. Next. So we'll do 12 inches. Next. And we'll do 15 seconds. Next. And we'll do 0 boost. Next. So now we begin the process. Begin the process. You're prompted to put the screen in place because it's already been communicating. Wait till it stabilizes, and then what we're going to do is put the sample on. And as you can see, it responds back and forth. Next. And now what we typically would do is take the sample, put it on the machine, and press start. You see, you get an indication of your vacuum pressure and you get an indication of your time as it decreases. You can also pause the operation in the event that material is clinging to the polycarbonate lid to brush it back in to have an opportunity to be removed from the process. Then we just hit press. Allow it to finish. You then remove your screen with the retained sample, place it on the balance. And what I like about it is that you notice here you have your screen weight and then you have your sample weight. So you can always determine if, for whatever the reason, the sample has gained weight and now is greater than what you started with because of hygroscossicity, or it's too low and it'll create an issue. So we'll just accept that and then we'll press OK. So in this case here, again, just an arbitrary test. We have 45 micron. We started off with 8.49 grams. We ended with 2.81. So 66, I believe it is, 66.9 passed. Now that is strictly in the Lin-Lin. Unfortunately, you cannot see rosin Rambler because the rosin Rambler values do not become active until you have a minimum of 2 points to use for your calculation points. But I want to graph, and here's my graph. This is an Lin graph. It's displayed on the screen. However, it will be displayed on the printout when we run a printout, and we can just have it then hard copy. But I want to save it. So we're going to save it to this USB stick, and we're going to call it. Again, I've got to click on an icon here. Test 1. All right, next, save. Provided you have a USB stick in one of the 3 available USB ports, you will save it to that particular USB stick. Done. And we're finished. And that was the temporary recipe. If you wanted to create the recipe as we did before, then we follow through with the various recipes. So we'll take performing a 2-screen recipe in another segment